Hello everyone, myself Dr. GVL Prasad, Assistant Professor, Department of Automobile Engineering. So in this series of lectures, Engineering Drawing or Engineering Graphics through AutoCAD, today's session I will explain how to draw orthographic projections using AutoCAD. Okay, so orthographic projections. It is a technical drawing in which different views of an object are projected on different reference planes. Okay, so for example, a front view, top view and side view. Okay, so the different reference planes are horizontal plane, vertical plane, side or profile plane. Okay, so the front view is projected on a vertical plane, the top view is projected on a horizontal plane and side view is projected on a profile plane. Okay, so before going to actually jump into the content, so why these orthographic projections, why we need to learn, or where it is really useful. Okay, so if there is a 3D object, so the 3D object or isometric object we can see in a realistic way, we can present in a realistic way. Okay, 3D view, but sometimes we need to know more information about that object. Okay, for example, so most of you are doing shopping online, okay, Amazon or many e-commerce site. For example, if you are buying a mobile phone, so in order to a 3D picture, you need to know about the various things. So where the C port, charging port there, and where is the volume button, where is the fingerprint option. So these are all, there are a lot of information you need to know, because so these are all information we required before we are going to purchase. So that is the reason why, so we need to present a information about the object in a different ways, okay, different views, so that full information can be presented, so that customers can this is not only for mobile, so anything, any object we are say we need to present to some customer or some client, so you need to project the real object 3D view as well as all views of an object. Okay, right. Next, okay, planes. These are all the principal planes: horizontal plane and vertical plane. Okay, so you know that horizontal plane and vertical plane. And then coming to a profile plane. Okay, the profile plane is where you can project a side view. So there is always other planes are auxiliary inclined plane, so which is inclined to horizontal plane, auxiliary vertical plane which is inclined to your vertical plane. But here mostly we will use a horizontal plane, vertical plane and a profile plane. Go to the next slide. So here, look at this. So this view you can clearly see the profile plane, horizontal plane and vertical plane. Okay, right. So in this orthographic projections, first angle projection, third angle projection, two types of projections are there. So mostly in India we will use a first angle projection. Okay, so in this entire lecture I'll talk about only first angle projection, right? Why first angle projection and how? First angle projection is said when you project an object keeping the object in a first quadrant. Okay, so if you kept the object in a first quadrant and project, so then it is called a first angle projection, right? So when in a first angle projection, so okay, so in a space you have a vertical plane, horizontal plane, you can divide the space into vertical and horizontal plane. When you coming into chart or when you draw on a screen, you have only one plane, right? So normally in a space you have a different planes, but when you are doing on a paper or when you are doing on a laptop or computer, you have only one plane, that's all. So but you need to split into a different planes. So for this, anyway, vertical plane will be vertical. So as a procedure, what we supposed to do, we will rotate horizontal plane clockwise 90 degrees. Look here. So this way. So we are rotating the horizontal plane clockwise 90 degrees, so that horizontal plane will come exactly below the vertical plane. Okay, you will get the top view on a horizontal plane and front view on a vertical plane, and a profile plane also rotated. Okay, so when you rotate, what happens? Whatever the left side view you are seeing and you are projecting on the profile plane, so that will be come on the right side of your front view. So that is the reason why. So when I start drawing, I'll ask you to draw left side view on right side of the front view. Always right side view on a left side of the front view. The reason is like this, because this is the profile plane. I am projecting the left side view on a profile plane and I am rotating the profile plane like this, so that my left side view come on a right side of the front view. And one more thing, always left side view and right side view associated with the front view. Okay, front view first and below top view and left side right. So this is about the first angle projection. So when you come to third angle projection, it will change. I'll show you when I go to. Okay, right. So you have to keep in remember exactly you have to draw like this only. So front view, below that top view, and left hand side view, right hand side view. Next one. So here he mentioned a third angle projection. So third angle projection is when you keep the object in a third quadrant and project, then it is called a third angle projection, right? So when you keep object in third quadrant, when you keep object in third quadrant, what happens? So the front view will be on vertical plane, okay, below, and top view will be up, left hand side and right hand. Left hand side will come on left hand side, right hand side will come on a right hand side. So that is how in a third angle projection, okay, right. Just crisscross. So when in a projection, when I thought projections of points also, when a point is in a first quadrant, front view is above XY line and top view below XY line. Okay, third angle projection. So third quadrant, when you keep the point in a third quadrant and project, top view is above XY line and front view is below XY line. That is what we did actually. But anyway, in examinations, you will get only first angle projection mostly. So learn first angle projection only, right? Next thing, you may ask a question, sir, what about a third angle projection and fourth angle projection? So we have a second quadrant and fourth quadrant also. So why not you are not talking about the second and fourth angle projection? Yeah, you can do second and fourth angle projection also, but there will be overlapping happens. When you keep the object in a second quadrant and project both front view and top view above XY line, so overlapping will be there. So that's why we don't go for the second angle projection. Okay. So whenever people will ask in interview, so what about the second and fourth? They do exist, but we don't use because of the overlapping of a front view and top view. Same way, if you keep the object in a fourth quadrant and project it, so what happens? Both front view and top view comes below XY line. So overlapping happens. Right. Anyway, so this is the object I will take. Okay, simple object. So this object anyway, it is there in the ND Bhatta book only. So I took this object. So I will draw orthographic projections. Okay, so orthographic projections also for your reference I kept in the same, okay, side by side. Okay, so actually this is in third angle projection. In the textbook itself, he has given in the third angle projection. So anyway, I took directly, but I will do in a first angle projection only. So these images will be top view and front view. They will exchange. Okay. So and one more thing. So view. So which is first quadrant? Which is front view and which is top view? Which is left and right side view? How to judge? So most of the diagrams. So this diagram will be given for you in the examination. And you will ask to draw the orthographic projection. You will mention front view, top view, side view, maybe left hand side or right hand side. Any one view is fine in examination, right? So there is an arrow mark and X. So wherever it is there, so in this direction you have to see a front view. So this is the front view for this isometric projection. Okay, suppose when it will become a front view, so anyway, if you look from the top, that will become a top view. So this side you can see a right side view, so that can be drawn on a left side. If you see that from that side, it will become a left side view. So whichever the side you can see more, whichever the side will give a more information, that view you draw. Okay, you will ask only sometimes side view, just front view, top view and side view. So in that case, you need not confuse which side view I have to draw, front, left or right. So whichever the side of the isometric view you can see for more information, more clearly. So that side you can draw, no problem. Okay, right. Suppose if he is given arrow here in this direction. So total will change, because in that case this will become a front view. Okay, so previously whatever the right side view, that will become a front view actually. So this will become a left side view, top view anyway, top view. So okay, based on the direction given in the figure, so left front view and side views will change. Okay, don't confuse. And one more thing, you may ask one more question, sir, if no direction is given, so arrow or X is not mentioned, so in that case which side or which particular view I can take as a front view, then it is your choice, no problem. Somebody, if this X is absent, it is not there, arrow is not there, so someone may take this as this direction as a front view, or some may take this as a front view, so no problem. Obviously if nothing is given, so you can your choice. Okay, right. So next I will go to the AutoCAD window. I'll keep a side by side so that I can, okay, we can, okay, right. See, I'll draw some boxes so that it can be done easily. What I will do. Approximately I have drawn some. Okay. The outside, just here up, just for your reference, you can draw. Okay, I have drawn and I have divided into some. Okay. So you just divide it into, okay, 4 boxes, so that you can draw front view here, you can draw top view here, and you can draw so okay, so anyway, right side will left side, so I'll draw front view, top view, and left side view here. Okay, so right, first I'll draw front view. So what is the front view? So this is the front view. Okay, look here, this is the front view and this is the top view. So this figure, okay, this kind of orthographic projections, mostly you are going to do with the help of the offset command. Mostly the offset command is very much helpful for you, so you can do it by using offset command. So first you have to understand the drawing, so directly don't jump into, okay, so first understand. So in examinations you have to arrange a space such that, so you can draw front view, top view, left side view like this. So somewhere front view, somewhere top view, don't draw like this corner front view, this corner, so don't draw like this, you lose marks. So it should be, pattern should be like this only, front view, top view, left side view, right side view, it should be like this only. So you have to arrange that size. Okay, so normally in the examination you have to, okay, they may always, we use it to teach some size 594 comma 420 something. Okay, so later you can enlarge also, just not only, okay, if it is not sufficient for you, so you can enlarge, no problem, just click it and then drag, no problem, put it and drag, no need, it need not be 590 by 420, so it can be bigger also, not an issue. Okay, so you can simply select and then edit, drag, you can do dragging. Okay, right. So first of all, so look at this diagram. So what is the total length of this diagram? So 18, 20, 18. So total 56. 56 is the length. And what is the breadth or width? 32. 32 is the breadth and width. And then what is the height? Look here, all the dimensions, 8. Okay, 8 is the height. And then this wedge, if the wedge is 18, I think 16, 18, 14 and 24. Okay, simply you can do it. So what I will do, first I will take a line command. So total 56, right? So I'll draw 56, 56, right? And what is the height? 8 is the height. I'll 8 and then 56 and then 8. Okay, so this is how you can draw the first thing. So with the given I have drawn. Okay, right. So next, see the front view, observe. So there is a step here, one more. So from here at a from this end at a distance of 12, there is one step. So you have to draw like this. See, mostly I am explaining the drawing procedure. I am not explaining, I am not much concentrating on how to convert isometric into orthographic. Okay, so just I have given some introduction, and mostly once if you understand, so then how to draw this one into orthographic ways. Mostly I am concentrating on orthographic. Okay, so meanwhile I am explaining figure also. Views conversion and all I am not much deeply going into this. So you can draw a rough sketch on the paper and then proceed, then it will be good for you. Okay, so write 12 and 18. So I'll go to offset here. So what is the offset? Select the object. So this is the object I want to offset. How much? 12. Okay, right, 12. 1 minute. So offset distance, enter offset distance 12. Okay, like this. Okay, after that 18, one more is there. So what you can do, again go to offset. Okay, so same, this time 18 this side. Okay, so sorry, not that one, 18 this one. Okay, right, you got it. So do it other side also. Here also same, this side also 12 and 18. So go to offset 12, this one, right, again offset 18. Okay, right. So hope you are already thorough with the drawing. I'm explaining one way of doing it. So if you anyway, whatever the way it is convenient for you, you can do that way, not an issue. So those who are confusing, for them it will be helpful. Okay, right. So I have done this part, and then I have to draw this one. In the front view, how it looks like? It looks like a rectangle at a height of 16. Okay, what I will do is, so from the middle, I'll draw one vertical line at a height of 16 mm. Okay, right. So this wedge thickness is 8 mm. So either way, I can offset a 4 mm. Okay, 4 mm. 4 mm, 4 mm, right. So I'll join, right. This is not required. I'll remove it. So done. The front view is done. So if you want to keep the dimension, go to linear, keep it. So which way you want? Okay, so 12 is there, you can keep 12. So I'm not able to see, so I'll go to edit and then dimension style. I will edit, modify, arrows and symbols 5 and text 5 primary units. Okay, right. So 12 mm. So and then again go to linear, and then this 18 is there, that also you can keep it, no problem. If you feel that it is big, you can reduce the size, dimension style, dimension style, and modify and reduce the size little bit. 5 become 3, and text also 3. Okay, somewhat right. So like this you can keep the dimension. Okay, what is the height? Height is 8 mm. So you can keep that also. Take linear. Okay, right, 8 mm. So here also repeat the linear. You can keep this height. So like this, wherever this dimension is required, so that way you can keep it. Okay, right, you can use the color, different color also. Right, so next coming to top view. So exactly below this you have to draw top view. So okay, for this what I will tell you is, better keep a guideline so that it will not deviate. Okay, so better draw guidelines. So from here you can draw a guidelines so that these dimensions exactly matches. Okay, right. So if you want, you can keep a guideline so that you can draw in between. Okay, so this is the top view. Okay, this is the, sorry. Okay, this is the top view. So anyway, you know the dimension total 56. Okay, so how much this one? 16, 12, something like this. Okay, here no need to find the angle. Wherever you can see the incline things also, don't try to find it. I know students are good at mathematics, engineering students are good at mathematics, but you are trying to use a Pythagoras, trigonometry and all to find out the angles here. Don't. You can find out the incline, everything in a geometric way. Don't use a mathematics here. Okay, unnecessary time waste. Okay, right. So what I will do next thing, so I'll take a line command. I'll first of all wait, I'll so anyway 50, this will 56, then coming total 16. Okay, right. So I'll take a line command again. So from it's okay. So anyway, I have drawn this. If you don't want to means you can remove this. Anyway, I have drawn already exactly. So 16, this is 16. After this is 12, right? 12 is there. Okay, right. Okay, then anyway, that same way here also, this side also. How much? 16 and 12. Fine. So total this is 32, right? So offset this one by 32 so that you can get everything. Okay, so go to offset again. So 32 is the offset width. So this one offset 32. Okay, what happened? Okay, 32. So better, what I suggest you draw one midline. Okay, so later you can remove it. For this guy, just from the middle of this one, draw one line. So later you can remove it, not a problem. So after this, what happen is, see, so this is 20 anyway. So what you do, offset 20, 10, 10 offset, and you can join this side, this side. So this front is 20 actually. This is 20 given. Look at the my cursor. This is 20. This is 20. So in the middle I have drawn one line. So I can do offset 10, 10, and then I'll connect to this. Okay. So go to offset again. 10. Either side I will draw 10 and 10. Okay. And then what I'll do. So I'll join this. This and this. Okay, right. So this is done actually. If you want to go to trim, you can trim, right? So later you can remove this one also. Okay, middle, keep the middle line. So right, what happens here, you know, there is a wedge, right? That wedge, what happens? The wedge 8 mm thick, and then a total 24, and then there is a step at 14 also. Okay, first go to offset 4, either side 4, 4. This side 4 and this both sides 4, 4, and then so offset this one 14 and 24. Offset 14, offset 24. Right. So later you can do trimming. Right. Okay, remove this one. So you got so exactly, so you got the top view. Okay, so if you want keep the dimension, you can keep the dimension linear, whatever missing here. So avoid the redundant dimension. So whatever the missing dimension, that you can do it. Okay, right. So here you can do, right. So front view is over and top view over. So I need to draw the I can see right hand side more information. So for right hand side I supposed to draw on a left hand side. Okay, right. So this is the, so what I said, so from the front view dimensions will coincide. So what I can do, I'll draw a guidelines. Okay, I'll put a guidelines. So then I will draw. Okay, okay, right. Okay, then I have to draw here, in third angle position, left hand side is left hand side, right hand side is right hand side. So this right hand side I want to draw actually. So anyway, you can look how you are looking this one. So how you look, if you look at from this, so this will become a two steps. Okay, this is anyway two steps, and this is like a wedge shape. I'll draw how this one is. So exactly this you are going to draw actually. Okay. Um, so in this 32, what happens? 16 and 16, 2 has there. Okay. Okay. So anyway, you have to draw like this. So properties, go to properties. Total 32. So from here I will draw 32. So anyway, this one 32. Okay, done. So in the middle 16, there is a step 16, 16, right? So you have to draw this one. So you can remove, if you want, you can remove the guidelines. Anyway, I have drawn completed, so remove it, right? So this I have to draw. So what is the height? Look at this. This I have to draw. What is the height? Height is 16 and it is coming 14 and 24, right? So what I will do from here, I will draw 16, sorry, height 16 and this side 14. Okay, so at a distance of 24. Okay, from here 24, right? So from here 24, what I can do, what I will do, I'll offset this by 24. I'll go to offset 24, offset this by 24. Okay, right? So take a line command and join it. That's all. I think height little bit change. Anyway, I have draw guidelines, right? So what happened? Guideline of drawing guidelines are low. Also, it's look some bulky. So I think I took a more height. 8 only height, I think. Okay. So something, it should be height 18 only. 8 only. So I'll do one thing. I'll trim it. So excuse for this. In a figure correct only, I took a height guidelines. I think I have drawn guideline from here. That is the reason why. So first of all, you should draw like this. Okay, right. So I'll select it and then connect it. Right. Right, this way. Okay, right. I took from top, that's why. So it should be like this. So step. Okay. So if you want keep a dimension, you can keep, no problem. So keep some dimension at least. Okay, 16. Okay. So like this you can keep it. Okay. So dimension and all, if it is in a different color, it's look good only. You can differentiate drawing and dimensions. You can take like this. Okay. So this is how you can draw the front view, top view and side view. Okay. Right. Okay. Right. So like this, as I said, you have to dimension very right. Okay. So same way. So I'll explain one more diagram, isometric. So shall I go to the next one? So this is anyway stepped bar kind of thing. I think this is also in third angle projection. So in the textbook is given in the third angle projection. I'll do first angle projection. In that case, this is become front view and left side view. Okay, has drawn right side, but first angle we have to draw on right side. This is the top view. Okay, so I'll draw and I'll remove this one. So okay, if you want boxes, you can do boxes. Otherwise, you can directly draw, not an issue. Okay, so just for understanding, I given like this. So now, right. So I'll draw one more thing. Right. Okay, fine. So look here. So this is the one. Okay, here anyway is given front view and top view. Okay, right. First of all, read the diagram properly. Okay, so this is the step bar, steps. Okay, right. Total. So see, x he has given arrow in this direction. Previously he has given, previous diagram is given in this direction. Now like this. That's what I said. Whichever direction x, according to that it will change. Okay, right. So this will become a front view. See what you can see from the front view: 104 and height 48. Okay, so draw a box kind of thing and then steps and all. Okay, so first you have to draw a rough sketch actually. Okay, so I'll proceed. This is the front view actually. Okay, fine. So as I said, mostly we can do with the offset command only. Very useful offset command. Okay, right. First draw a line. So draw a line of 104, 104, height 48. Okay, so it's a box kind of thing. No? Anyway, so you can draw close figure. Okay, right. So after this, so this is 24, right? 24. So offset 24. Go to offset 24, then offset it. Okay, right. So then what is the step height? Each 16, 16, right? Offset it to 16, 16. Go to offset. It's very simple diagram, this one. Okay, so after that go to trim and trim it wherever it. Trim here, here, here. So dimension I will keep at the end. So front view is over. Okay, left hand side view I will draw right side view. So first I will draw top view as well. So top view, what you can see this one 104 and 72. Okay, anyway, so this dimension will coincide. Okay, right, exactly you need to draw like this. Okay, right, anyway it will come 104, 104 and 72, 104, 72. Right. Okay, so if you want you can move little closer, not an issue. Right, so after that what happens? Look here at the top again 24. So this side 24 and 24, 24. Top side step height 16. That's why we did a 16, 16. And when you are looking from the top, the step width it is 24, 24. So now offset 24, 24. Go to offset 24. Say this side 24, 24. And this side also 24. Right, so you can trim, or you can trim, right? So you can trim this one and this one and this one. Right, got it. Next, left side view. So this you can draw height, anyway it will match with this one. Okay, right. So what is this? How much you are seeing? 72, right? 72 you are seeing on a side view, and height anyway 48, 72. Right, done. So after that, okay, what is happening? Side view, look from here 16, 24, 16, 24, 16, 24, like this you can draw. Okay, it may be overwrite sometimes from here. 16, this side 24, half 16, 24, 16. So done. So this is how. Okay, if you want to keep the dimension, you can, no problem. Go to properties, take a different color, and then linear. So whichever you want. So front view you are able to see 104. Keep this 104, and front view height you are able to see height also. This side height also. Okay, right. Don't need not repeat. Okay. So this is already 104. Again, you need not given. So something like this. You can give the dimensioning. Okay. So this is how it looks like. Front view. Very easy. So I'll take another one. So like this, you can draw any complicated figures also. As a time limit, I cannot do all the things. Only, so whenever you can see this, keep in mind that two things. One is where is the front view, where is the top view, left side view, and right side view, and use the offset method and center line. Wherever required, you draw the center lines. Okay. So that way you can do. Curves also means you can draw arcs. Okay, I have not taken any curved figures here. Maybe in a future lecture series, I will in next thing I may draw curved one also. Right now I don't have any curved one here. I'm not. Right. So this one I'll show you this one. Okay, okay, so front view. So look at this. So this is in first angle projection only. Front view, top view, left side view, right side drawn. Okay, right. So front view, what is the total length? 75, 25, 25, 25. So here height 25, 20, and then right. Okay, so I'll show you how to do it. Take a line command. Oh, total 75. So I'll change the color first. $75. Height 12. Okay, right. 75. Okay, right. So you have to offset 25, 25. Go to offset 25. Okay, again 25. Right. Fine. So then height 25, 20. Okay, so this wedge. So from here I will draw 25 height and then 20. So I have to join somewhere here. So how to pick this one? Exactly 20 from here. Okay, 20 from here. So what you can do, I'll tell you one more method. So what you can do, I want to, this is, so this is connecting at a 20 from this end. So what you can do, I'll tell you two methods. First one, you can offset by 20. This one you can offset by 20, so that you can have one reference. Then straight away from here to here you can join. That is a one way. So another way is what I can do. I'll teach you one more method from. Okay, so take a line command. So line command, immediately what it does, so specify a first point, right? So this is the first point actually, but this is not my first point. I'll take this as a base point. Okay, so for this I'll use command from, from, use from, and take this as a base point, and distance 20, right? At the rate 20 is less than 0, so that it picked here. Okay, right, you can join. Okay, look here. So it will not draw a line. So that's a simple method. Okay, so use from, I'll tell you one more thing. Simple, you can do it in a quicker way. And right, take a line command. So after this, use from. So base point, this is my base point. So at a distance of what? 20, at the rate 20 is less than 0. Okay, I pick it here and then, oh, something wrong. from. So this is the base point at the rate 20 less than 0. and you picked here and then do it. So this way you can do it very easily. So I just showed a front view, so you can draw similar way top views and all also. Okay, so and one more thing, see here you can see a dotted line here something. So why dotted lines? Wherever, you know, if you're not able to see the full thing, see when I am looking from the left side view, this slot I'm not able to see. So in this case I just kept a dotted line. That means there is a portion, something material is not there. So that's why people will understand if you keep a dotted line. So at a distance of 12 mm from this end, there is a material gap is there. So that way you can understand. Okay, right. So with this I can conclude you got some idea how to draw orthographic and how to draw orthographic projections and isometric to orthographic. Okay, done. So in the examinations, this isometric view given, you have to draw orthography. You need not draw this in this case. If you ask or draw the orthographic projections, in this case you only draw this, not this one. This is not required. Okay, so there is another case, so where you can give orthographic projections and you may ask to convert into isometric projection. So that type of questions also there. Mostly that type of questions will not come, but anyway in the next lecture I'll explain. So this orthographic projections are given, how to convert them into isometric or pictorial views. That is also there. I'll do in the next lecture. Okay, right. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.